Hello everyone. And welcome to the Mathematecher channel. We have the sequence un, which is defined by its general term, un equals 5 times n cubed plus n. At first, we're asked to make sure that the difference between any two successive terms, which is un plus 1 minus un, equals 3 times 5 times n plus 1 plus 2. And then, to prove by induction that the term un is divisible by 6, whatever the value of the natural number n is. So we will begin by verifying that the difference un plus 1 minus un equals 3 times 5 times n plus 1 plus 2. So according to the definition of the sequence un plus 1 minus un equals 5 times n plus 1 all to the power of 3 plus n plus 1 minus 5 times n cubed plus n. Now, by extracting the number 5 as a common factor between the terms 5 times n plus 1 all to the power of 3 and 5 times n cubed, and cancelling out the terms n and minus n, we find that un plus 1 minus un equals 5 times n plus 1 all to the power of 3 minus n cubed plus 1. By expanding n plus 1 all to the power of 3, we find that un plus 1 minus un equals 5 times n cubed plus 3 times n squared plus 3 times n plus 1 minus n cubed plus 1. As the terms n cubed and minus n cubed cancel out, we find that un plus 1 minus un equals 5 times 3 times n squared plus 3 times n plus 1 plus 1. By expansion, we find that un plus 1 minus un equals 15 times n squared plus 15 times n plus 5 plus 1, which equals 3 times 5 times n plus 1 plus 6. By extracting the number 3 as a common factor in this sum, we find that un plus 1 minus un equals 3 times 5 times n plus 1 plus 2, which ends our verification. Now let's prove by induction that the term un is divisible by 6 for every natural value of the number n. So for our proof by induction, we will notice Pn, the property that says that the term un is divisible by 6. Then we will verify that the property Pn is true for the value 0 of n, which is the first step of our proof by induction. And then we will prove that the property Pn plus 1 that says that the term un plus 1 is divisible by 6 is true, assuming that the property Pn is true for a random natural value of the number n. So, for n equals 0, we have P0 is true, as the term u0, that equals 0, is divisible by 6. Let's mark this as assertion 1. Now supposing that our property Pn is true for a random natural number n. As the product of any two successive natural numbers, n and n plus 1, is even, then our number, 5 times n plus 1, plus 2, is divisible by 2. So its multiplication by 3 will be divisible by 6, which equals 2 times 3. And as we found in the first question, that the difference between the terms un plus 1 and un equals 3 times 5 times n plus 1 plus 2. Then the term un plus 1 equals un plus 3 times 5 times n plus 1 plus 2, which is divisible by 6, as our term un is divisible by 6, by assumption. So we have proved that the property Pn plus 1 is true, assuming that the property Pn is true. We will mark this as assertion 2. Now, as assertions 1 and 2 represent the two steps of our induction proof, we deduce that our property Pn is true for every natural value of the number n, which mean that the term un is divisible by 6 for every natural number n. Thank you for watching the video. Share it with your friends and give it a like. Subscribe to the channel and activate the notification bell if you haven't yet. And until the next video, have a great time.